I did post a video lesson, I think last week, right? And hopefully some of you watched it. If you have not watched it, please go and watch it. It basically just covered applied problems. Pretty straightforward. So it's pretty easy lesson. So just go watch it. It's pretty short, only like 30 minutes, and you can do the homework. All right, and today isn't going to be that hard either. It's just going to be a unit review because we're seeing a lot of students. Okay, maybe because of the time change. All right, so if you can see my screen, say yes in the chat. If you cannot, say no. All right, so can you see my screen right now? Yes, all right, very good. So now let's we're going to go with a unit review over the systems of equations. So this is our schedule. We're just gonna go over some homework questions. All right, gonna review some substitution and elimination. All right, and then we're gonna review the applied problems. All right, and then we're gonna go over some review problems. Okay, so let's first go over some homework questions. So everybody take the time to just post your answers for this. All right, so we got one answer. Good. Okay, from William. All right. Also Elaine also has the same answer. Very good. Okay, so let's see. Who wants to volunteer to show us how to do this? Okay. William, let me check the chat first. Okay. And also Kaylee also got the correct answer. Very good. All right, so William, could you show us how to do this? First, set the variables.
Okay, so I set S as the senior ticket price and C as the child ticket price. So the equation I did was, the first equation is 3S plus C equals to 38, and the 38 is $38. And the second equation is 3S plus 2C is 52. So after that, I used elimination to solve for C. So I just multiplied the second equation by -1 and then combined the equations. So I got 3S plus C minus 3S minus 2C equals to 38 minus 52. So negative C equals to negative 14 and C equals to 14. After that, wait.
Keep going.
After, wait, what?
Just never mind. Keep going.
Okay. So after that, I plugged 14 into every C into the first equation. So 3S plus 14 equals to 38. So 3S equals to 24 and S equals to 8. So the senior ticket price costs $8 and the child ticket price is $14.
Very good. Great job. All right, so did everybody understand this process? Very good, William, very good. And I like how you used elimination instead of substitution. That was the best choice because obviously you could have just subtracted the equations, right? Because substitution would have been too slow. All right, so very good. It's very important to be able to know which one to use. So great job. All right, let's go on to the second one. All right, so this is a little bit different from the last problem. All right, let's look at this. So we have some differing answers. So Elaine says the boat is 12 miles per hour and the speed of the current is 9 miles per hour. All right. Okay. And William says the speed of the boat in still water is 6 miles per hour and the speed of the current is 4.5 miles per hour. Kaylee says 12 and 9 also. All right, this is very interesting because William's answer is different from the other answers, but they're all in the same ratio, right? Because 4.5 is 3/4 of 6, and 9 is also 3/4 of 12, right? So let's see which one is correct. All right. Um, Kaylee, could you explain how you got your answer?
Sure. So it gives you the entire time, so I changed it into miles per hour. So I turned the two. Okay, so when they traveled downstream, it took 10 hours. So 210 miles in 10 hours is equal to 21 miles. And then 200 miles is the same as 3 miles in an hour. Then
Hold on one second. Could you repeat that? Your audio is very off. Can anybody hear it? Your audio is kind of like cracking, right? It is. Yeah, all right. There's a little bit of audio crack. Could you repeat that for us? Also, make sure you set your variables first. All right. So
Okay.
let's see here. Yeah. Okay. Thanks.
So my x is the speed of the boat, and then my y is the speed of the current. And so what I did first is I converted
Hold up.
the
Let me set the variables. All right. Go on.
what I did is I changed the hours in miles, so it's per hour. So 210 miles in 10 hours is equal to 21 miles per hour. And 210 miles in 70 hours is the same as 3 miles per hour.
All right.
So we know the way downstream is is we know the way downstream is the speed of the boat plus the speed of the current. So if we add those two together, we would get the speed downstream. So x plus y is equal to 21 miles per hour. And we know the way upstream is the speed of the boat minus the speed of the current. So x minus y is equal to 3 miles per hour.
All right.
Then I added those two equations together to get 2x is equal to 24 and x is equal to 12 miles per hour. And then I plugged it in, so x plus y is equal to 21 miles per hour. So if we subtract 12 from both sides, we get y equals 9 miles per hour.
That's very good. But there's a small problem. All right. Let's look at William's answer. All right, William, could you explain your answer? Let's see what's the difference here.
So I used S is the speed of the boat in still water, and C is the speed of the current. So,
Hold up.
wait, I did S is the speed of the boat
Yeah.
in still water.
There we go. There we go.
Okay, so since the speed of the boat going downstream is the speed of the boat plus the speed of the current, then S plus C has to be 210 over 2 divided by 10, which is basically 105 tenths. And the speed of the boat going upstream is the speed of the boat minus the speed of the current, which is equal to 210 over 2 over 70, 210 halves over 70, which is also equal to 105 70ths. And after that, I simplified the two fractions and then combined the two equations together. So I got 2s minus s plus c plus s minus c equals to 21 halves plus 3 halves, which is equal to and 21 halves plus 3 halves is equal to 12. So that just means, so after that, after we eliminate all the c's, we get that s is equal to 6. And after that, I plug 6 into every s in the first equation. So I got 6 plus c equals to 21 halves. So c equals 9 halves, which is equal to 4.5.
All right, so that is actually the correct answer. All right. So let's look at it. All right, miles per hour. Miles per hour. Kayla, do you understand where you got it wrong? Because you got to look very carefully at the problem. Right? So the boat traveled 210 miles downstream and back. All right, that's not just one trip downstream or one trip upstream. One trip downstream is actually 105 miles because the distance is cumulative. All right, it's cumulative downstream and back. So the whole trip is 210 miles. One downstream is 105. All right, so essentially what you're doing here is actually you're saying that it's actually 10.5 miles per hour here, and essentially you're doing 105 over 70 here, which I need to get my calculator. 105 over 70, which is 1.5 miles per hour. All right, this is 1.5 miles per hour. And if you plug it into these, you can see that it's the same equation that William set up. So it's just this very small mistake. All right, Kaylee, because you forgot that the whole trip is 210 miles instead of just downstream is 105. All right. So do you understand your mistake? All right, make sure you read the problem very carefully. All right. All right. Very good. Very good. All right. So let's move on to the third problem. All right. So this is quite a long one. All right, let's look at our answers. I think everybody has the correct answer. 8 and 22, so there's a consensus. Very good. All right, so the State Fair is a very popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. All right, so the senior class at High School A rented and filled 8 vans and 8 buses with 240 students. Okay. And the high school rented and filled 4 vans and 1 bus with 54 students. Well, you can see that High School B is very significantly less students than High School A, right? Every van had the same number of students in it as did the buses. Find the number of students in each van and the number of students in each bus. All right, so let's say V is equal to the number of students. How about the capacity of a van? And B is equal to the capacity of a bus. You can see that we have our equation here. 8V plus 8B is going to be equal to 240. And then 4V plus B is just going to be equal to 54. So what we can do here is we can actually multiply the second equation by -2. Let's do that. Negative 8V minus 2B is going to be equal to negative 108. All right, we multiply everything by -2. Now we just add. All right, you can see when you add, the 8V cancels out. So you're left with the 6B is going to be equal to 132. Right. So B is going to be equal to 22. Therefore, if you plug it in, B is going to be equal to 8. Right, so that is the capacity of the vehicles. Very good. All right, so good job on finding the correct answer. So now let's just a couple review things. All right, so we'll go over this real quick. Make sure students that are not very comfortable with these methods know what they're doing. Okay, so let's do this. So review solving with substitution. What you need to do is you need to find the value of one variable. All right, so solve for one variable. All right, so what we're going to do is we're going to solve for one variable. You can see here and see that y is going to be equal to x. So they have equal values, right? So once you know that y is actually going to be equal to x, you can see that you can plug y in, actually plug x in for y, right? Because they're equal. So they can be used interchangeably, right? They can be used interchangeably. Therefore, you can get 3x is going to be equal to y, and this can be done vice versa. All right, you know that x is going to be equal to y, so you can plug y in for x, like this. Right? 3y is going to be equal to 6, y is going to be equal to 2. And then since they are equal, x is also going to be equal to 2. All right. So just a little review of substitution. In the homework, you really didn't need to use that much substitution. Most of them were elimination. But definitely review substitution, because in some system equations, substitution is the way to go. All right, so let's solving with elimination. All right, so that we can solve it the same way with elimination. So what we're going to do is we are going to move the x to the other side. So therefore we get something like this. All right, you see the negative x plus the y. All right, so what we can do is we can actually add everything to the first equation. So if you add this side of the equation to this side, we also need to add this side of the equation to that side, because they're equal. All right, if you add a 1 value to the one side, you're going to have to add the equal value to the other side. But since x plus y is going to be equal to 0, right? You're still going to you're going to need to plug that in. Yeah, you're going to add it to the other side, right? So let's do that. Okay, so let's do, you see the x cancels out, right? So you get 3y is going to be equal to 6, and therefore y is going to be equal to 2. And also get that x is going to be equal to 2. And also eliminate the y if you move it like this, right? You move it like this, okay? And then you can eliminate y, all right? So pretty straightforward. We've learned this a lot of times. Just a little bit of review for the students that are not yet comfortable with this. All right, and let's review word problems and applied problems, since that was the subject for the last class. All right, so let's review a little bit. So everybody, if you want to unmute or type in the chat, please do so. So everybody needs to participate. So what are some things that you need to keep in mind when solving word problems? All right, just think about if you were taking this class, what are some things you need to think about when you are solving a word problem? All right, what are some tips that you can give? All right, does anybody know any tips to do when you're solving word problems? Or read the entire problem. Very good. All right, so read the entire problem. All right, so it's very important to read. Actually, uh, some tips. Okay, read the entire problem. Very important. All right, so you might get something wrong if you do not read the entire problem. There's a lot of valuable information that you need to for the formation of a equation, right? So you need to read the entire problem, get all that valuable information, and then you can solve the problem. All right, what are some other tips that we have? All right, yes, know what you're solving for. Answer the question, right? Answer the question. Sometimes X is not the answer. All right, answer the question. Once you solve a variable, all right, you're not done with the question yet, right? You're not done with it. All right. Once you solve the variable, sometimes you need to add 3 to it to get the actual answer, right? So just solving the equation is not the end of the problem. All right, so look at the numbers carefully. Very good. All right, so look at the numbers. Look at the numbers carefully. All right, so if you don't look at the numbers or the information carefully, all right, you cannot solve the problem very good, right? Remember, Kaylee, you forgot to look at it very carefully, right? And then you got an incorrect answer. So make sure you have to you have to look at it very carefully, all right? Get all those subtle details. All right, check your work. Right, check your work. Very nice. All right, check your work. All right, and this is another method you can directly incorporate in your homework, and it can be transferable to all homework. Right? After solving the word problem, check it for feasibility. All right, does anybody know what feasibility means? All right, it means is it reasonable or not? Is your answer reasonable? Okay, look, let's say for this previous question about the veins in the buses. All right, how many students can the bus hold? You get an answer of 3,000. That's not very reasonable. So you might want to go go ahead and check back to your work. All right, let's say the bus is able to hold a maximum of -3 students. How do you get -3 students? It's not very feasible, right? Again, so you if you get an answer like maybe like 30 or 22 or 20, right? And that's very reasonable. That's a very reasonable number for a bus. All right, and then check for reasonability. All right, is your answer reasonable? And also check your word process. Right. Okay. Very nice. So let's do some review problems. All right, let's do some review problems. So this one, um, use any method to solve. Use any method to solve. All right, let's look at this problem. So William said 2, 3. All right, very good. So this one you can use substitution for because we already have x isolated, sort of isolated here. So let's do this. All right, so x is going to be equal to negative 8y plus 26, right? All right, and then all you need to do is plug in negative 8y plus 26 for x, and then negative 40y plus 130 plus 2y is going to be equal to 16. All right, then you're going to get 38y is going to be equal to 114. Y is it's going to be equal to, what is it, 3? Yeah, I think 3. Okay. All right, and then x. All right, after you plug in this, x plus 24 is going to be equal to 26. X is equal to 2. All right, there you go. All right, next problem. All right, let's solve this one. William says 1, 5. Very good. So for this one, we already know what Q is, right? So Q is going to be equal to negative 2p plus 7. So plug that in. Like this. All right, so let's see. 8p plus 7 times negative 2p plus 7. Yeah, all right, it's going to be equal to 43. 8p minus 14p plus 49 is going to be 43. Negative 6p is going to be equal to negative 6. P is going to be equal to 1. All right, plug that in. 8 plus 7q is going to be equal to 43. 7q is going to be equal to 35. Q is going to be equal to 5. All right, it's going to be 1, 5. Very good. Go on to the next one. Okay, let's solve this one. All right. So let's just move a couple of things. There we go. Let's multiply the first. Actually, let's multiply the second one by -2. So 4u minus 4v is going to be equal to -24. Then if you add them, you get -3u is going to be equal to 3. U is going to be equal to -1. 27 is going to be equal to -1 plus 4v. 28 is going to be 4v. V is equal to 7. Therefore, you get -1, 7. Very good, William. All right, number 4. All right, let's go over this. All right. So for this one, we can just use substitution because we already know what R is. All right, you get 156 plus 15s plus 44 is going to be equal to negative 7s. All right, what is this? This is 200. Very nice. It's negative 22s. S is going to be equal to 200 over 22 is going to be equal to a very ugly number. It's just 100 over 11. I think it is negative 100 over 11. All right, and then S, 52 plus negative 500 for 11 is going to be equal to R. Okay, multiply everything by 11. 52 times 11 is going to be equal to 500. 72, all right, minus 500 is going to be R. R is going to be equal to 72. All right, and since we're running out of time, I'll just do the last one. So the difference of two numbers is 3. So X is the big one, Y is the small one. So X minus Y is going to be equal to 3. X plus Y is going to be equal to 13. Add them up. Right, 2x is going to be equal to 16. X is going to be equal to 8. Y is going to be equal to 5. All right, that's all for today. Thank you for listening. All right. I'll see you. What? All right, bye.